Hello. It's a bit late, but it's a bit random at the moment. Unfortunately, I'm trying to balance a wife who's very pregnant and all sorts of bits of work in lockdown and things. So I do apologise a bit late, but this lesson is all about trying to teach you about algebraic fractions, simplifying algebraic fractions, and then using them to add and subtract fractions when there's algebra involved. So hopefully we will embark on making sure that we can cover all those things. If at any point things are seeming too difficult, just rewind, watch again. I'll try and go through it nice and steadily, but I'll try and make it make sense to people. There's also in the link below the video a link to some further questions you can do to practice the topic, but there's also lots of questions going to be throughout. It's quite intense, this one, so let's get ready to go. So, we are embarking on algebraic fractions. Algebraic fractions sounds like it's complicated. Purely, it is fractions that have some letters involved in them. And we're not going to be these people who get terrified by algebra. We're doing higher GCSE, which means we're not going to be terrified by the fact there's some algebra present. We're going to go straight into it and see what we are going to do with it. So, I'm hoping I should be able just to get straight on with it. So we've got algebraic fractions, and we're going to be learning about simplifying expressions, then simplifying algebraic fractions, then some adding and subtracting to algebraic fractions, and then we'll review what we've learnt at the end of the lesson. In order to be able to cope with this lesson, there's not too much we need to be able to do, but we should already be able to do linear factorising. That's where you've got two expressions and we just take a single a couple of things outside the front of the bracket to create one bracket. Quadratic factorising, where we're going to be creating two brackets, and quite important, remember, difference of two squares, because a lot of the exam questions end up being difference of two squares. So that's going to be quite important too, and to ensure that we're familiar with that, a little starter activity. So I recommend please pause the video here, have a go at the questions. I'm going to give no more than a couple of seconds because you can pause the video. And then we'll just go through some answers. So you can see this one. I don't know why I'm doing it in this order, but it's no harm done. This one should have gone to that. It's the hardest one on there. There's a whole video, I'm sure, I did way back on how to do quadratic factorising, but I'm happy to do another one. If anyone puts in the comments wants any help on how that comes about, please do ask. But basically, that is what the answer we should have got there. This is your difference of two squares. A square number take away a square number. Look out for it. Constantly look out for it. I will flag it up as during the lesson, but this is something that gets hidden an awful lot, is the difference of two squares. So make sure you can see when that's happening. We've got linear factorising, 3 lots of x plus 4, and finally just a normal bracket with a minus 9 and a plus 3. Remember, you could have the brackets either way around and it will still work. So hopefully if you didn't get any of those right, or you made mistakes on that, before you carry on with the video, I strongly suggest you go away and practice those skills until it makes sense to you, because the nature of higher tier maths is it builds on things you've already got. It won't be that you don't get this, but if there's any of these 4 soft skills you can't perform, it won't be that you don't understand algebraic fractions, it will be that you can't access them because there's a skill missing that you need. With that in mind, let's move straight on. So algebraic fractions, the expressions could be on the top, could be on the bottom, could be one of those, could be both. You can often simplify them. So the whole point of the question would be simplify these algebraic fractions. You're not going to be asked to just look at a fraction and go, oh, that looks pretty. We're going to be asked to simplify the fractions, but then follow all the normal rules of fractions. So just like 36 over 72 reduces all the way down to 1 over 2, simply because you can halve it, you can divide it by 3, you can divide it by 6. You're looking for the biggest number that divides by. So in that case, the example I gave you, 36 over 72, it divides by 36, both on the top and bottom, giving you 1/2. But we're looking for things in common. So you cancel from both the top and the bottom to simplify. And you can see this is a spot the difference, but we're picture, but we're now looking for things in common. And so in order to do so, I've got an example of how this would work. So here is a question which is clearly a fraction with algebra on the top and algebra on the bottom. And what we're going to do, in order to be able to simplify this fraction, we're looking out for how we can reduce it. Now, based on the things we did at the start, break the question down into the top line and the bottom line. And if I do that, I get x plus 4, x plus 2 on the top, and I get 4 lots of x plus 4 on the bottom. But you will notice both the top and the bottom now have x plus 4, that whole bracket, as a factor, because those two factors on the top have been multiplied together, and the 4 is multiplied by x plus 4 on the bottom. So what we can do is we can then cancel through those two lines, leaving us with x plus 2 over 4. And that is what it means by simplify. It's factorise and simplify, but it might just say simplify. This fraction here is exactly the same fraction as the question that we started with. It's just simpler. And that's what it means by simplifying fractions. Now, in order to understand this better, I'm going to head over to my whiteboard, where I can do a couple of examples with me saying hello to you in the corner of the screen. So what we're looking to do, it might not be algebra on top and bottom. Sometimes it can be just a simple idea of 8x plus 14 all over 10. It can be as simple as straightforward as this. So all we're doing here is we're taking 2 onto the outside, 4x plus 7 all over 10, but the 2 and the 10, it might be easier to think of this as, you don't have to write it like this, but it might be easier to think of this as 2 times 5. That is why the 2 cancels there, leaving us with 4x plus 7 over 5. And once you've got down to a single bracket, you do not need to include the bracket. Because it's all got the line underneath it, it is assumed there's a bracket there, so we don't need it. You don't lose any marks for taking away the bracket, you don't lose any marks for keeping it there. They're both the same. It could be there's algebra involved, but it might only be on the top. For example, x squared plus 9x all over 3x. If we want to simplify this, when we factorise the top line again, we get x plus 3. No, we don't. Mr. Harris is talking absolute rubbish. We get x plus 9, and then that's over 3x. So what can be cancelled here is the x cancels with the x from the top and the bottom. We're looking for things to cancel. We end up with x plus 9 all over 3. I chose the 3 on purpose because I want you to realise you cannot. It might be tempting to go, oh, that 3 crosses with that. It doesn't, because this is not 9. This whole thing is x plus 9. The 9 is technically involved with the x first before any division. So you are not allowed just to cancel with bits of it. And that's quite important. There's been some students I've been teaching who, when they came to do this, they wanted to cancel the 3 with the 9 because 3 and 9 go together. But the 9 belongs to x plus 9. So if you want, you can keep the brackets there to help you remember that. But you can only divide by the 3, and I'll give you an example where you could have done it. 4y squared plus 8y all over 6y. In this example, we now get 4y on the outside, y plus 2, and 6y. This time, the y's cancel first. 4 brackets y plus 2 all over 6. And then the 4 and the 6 cancel, leaving 2 over 3 y plus 2. And I must extend that fraction all the way through. So the 4 and the 6 are treated almost as if it was just like in standard fractions. 4/6 goes to 2/3. We've done the same. 4/6 has gone down to 2/3. So the 6 didn't cancel with the 2 inside, it cancelled with the thing on the outside because that was on its own. That's quite important. So if I head back to the PowerPoint, this is how the fractions get simplified. I've prepared some questions for you. There's 6 of them there. Okay. What I would like you to do is attempt to simplify them. Now, I believe, if I've got this right, I've prepared one to go through with you. No. We can describe the first one. So, if you want to, pause the video now, and that will allow you to then do all of these questions before I show the answers. I'm not precious over answers. You're not doing these questions for me, you're doing them to understand. And anyone who's tuning into my videos regularly will know that the point of learning maths has got nothing to do with getting the right answers. It's got nothing to do with being right or impressing the teacher. It has everything to do with learning and understanding. And so don't worry about whether you see the answers or not. It's about practicing these questions. So you've paused it. The answers would be here. And in that first one, you can see it broke down into u brackets u plus 3. But the bottom was u brackets 2u minus u. So minus 1. Hence the u's cancelled out. And in each case, there's been letters cancelling out that has helped us out. The next set of questions, these all involve a quadratic on the top. And a bit of a hint here, because we've been told to simplify it, we know one of the brackets on the top is going to be the bracket on the bottom. It's kind of, if you were doing this and you didn't know all the answers, and you didn't know that you had to do this, like at A level, and you're just playing around, rearranging, trying to cancel things out, you won't know to look for it. But because we were doing GCSE algebraic simplifying, we know, for example, in the first one, v minus 2 is likely to be a factor. So we can just look at, well, minus 2 times minus 4, and it's v minus 2, v minus 4. Hence, pause the video. You've had fair warning. Here's your answers there. V minus 4 is all that's left because it cancels out the other bracket. So basically the bottom bracket the bottom line cancels out one part of the double brackets that we end up with. So that's all of those answers. Finally, I did mention we'd be talking about difference of two squares. You should immediately see what you have to be on the lookout for is square number minus square number. Soon as you see that, it's going to be a plus version of the square root and a minus version. So f squared minus 4 will go to f plus 2, f minus 2. Hence, cancels out to f minus 2. Then we've got t minus 7 and q plus 1. Now, when we move on to addition or subtraction, I'm going to mainly focus on addition because subtraction works the same way as addition, just like in normal number fractions. This is not a completely new thing. I get very frustrated when people say, it's algebra, it's hard. It's no different from the stuff you were doing in year 6 and 7. The only difference is it's got some letters. If I gave you this question here, you can see 3 fifths plus 5 sevenths. The first thing you would all do is you'd go, it's 35 and 35 on the bottom. There, and you get 46 equals 1 and 11 over 35. Standard, right? The first thing you do is you make the common denominator and you change the tops to match that. Well, in that case, when we come to do one with fractions, and I've got ones with fractions on the bottom, not the fractions won't always be on the bottom, but in this case they are, the way you make these of a common denominator is you times all of the first fraction by x plus 3 over x plus 3. Sorry, not just by x plus 3. It has to be over because otherwise, if it's timesing by x plus 3 over x plus 3, you're effectively timesing by 1. All of the second one gets times by x plus 2 over x plus 2. What we can then do is head off to the whiteboard where I may have prepared this already so that we can carry it on. So this is where we got up to. I've done this. This, hopefully you observe, is the same on the top and bottom. And we know about fractions. Once they're the same on the top and the bottom, you are allowed to keep the same base. So x plus 2, x plus 3. Notice I'm not going to multiply it out here. I don't see the need to. I will multiply out the top bit. So I'm going to do 5x and 3 is going to be 5x plus 15. And 3x plus 6 plus 3x plus 6. This is why my final answer is 8x plus 21 all over x plus 2, x plus 3. And then as a final check, I look at my final answer and go, does this factorise? And it doesn't. 8 and 21 are not in the same times table, so we're not going to be able to factorise it. So this is why this would be my final answer. It may look like there's a lot of stuff going on there. Doesn't matter. This is a final answer because this is as simple as it can be. Answers in maths are... I hesitate to even use the word answer because this is the simplified form. Answer is a poor word to use. What we're looking for, the simplest form here, it doesn't go any simpler. This is just as simple as it goes. Hence we call it the simplest form. And that is what they're looking for when they say simplify this algebraic fraction. We're just looking for this form. Notice all I did was the same as I would have done if this was 5/8 plus 3/7. Notice, if it was 5/8 and 3/7, I would have turned that into times 7 and times 7, and that one into times 8 and times 8, giving me 35 over 56 plus 24 over 56. I would have done the exact same thing with numbers as I've just done with the algebra. I times it by the thing on the bottom, but on the top and the bottom, and I times the second side by the other bottom, the other denominator. In this way, we created a common denominator and two different bits that can then be added, because once they're the same on the bottom, you're allowed to add them. And what's what we would have done here? We would have got 49 over 56. As it was here, we got 8x plus 21 all over 2x plus 3, x plus 2, x plus 3. Heading back, this should mean that these questions are now accessible. But you may be thinking, oh, still, sir, I'm not quite there, and it's a bit much. You're expecting a lot of us. No worries. I've prepared it, so I'll do a couple of questions for you once you've had a go at these ones. These ones have all got numbers on the bottom, so they work exactly the same as normal numeric fractions. So here, in this first one, try and make them both over 12. So you would make it 3k over 12 plus 8 outside over 12, because we've times the right hand side by 4 over 4 and the left hand side by 3 over 3. Then you add both over 12, so you'll end up with 3k plus 24k minus 8. That means I'm going to end up with 27k, 24 plus 3, 27k minus 8 all over 12. That doesn't simplify anymore. Pause the video. You've had fair warning. And this is why the answers are here. You will notice this time I have broken it down, what we did. So you can see in the answers that the first thing is the simplified form and then the final answer. This should help you tracing where you went right or where you went wrong. Now I will point out, I have borrowed these questions from another person's PowerPoint on the Times Education Supplement TES website. Lots of resources for teachers. The person who's put all this together, I've borrowed some of their things. I'm doing this to try and make the videos as smooth as possible. So I will put it out there that this is not all my work. So anyone who tries to claim, oh, you didn't do it all, you're absolutely right, I've stolen some things. But that's what we have to do as teachers. We have to try and make it so that we can see everything we're doing. Okay, the next set, I promised I would do one for you because it's now got slightly harder. So here we are. And I've got v and v plus 1 on the base. So I'm going to make sure that I'm going to do this is going to become 4v plus 1 over v plus 1. Notice all I've done on that left hand side, don't want to make this complicated. Top and bottom have been times by the base of the other side. Here's the denominator on the other side, and it's been times by top and bottom. Then we're doing a takeaway. I mentioned that I'm not going to focus on takeaway as anything different. We're just going to leave it as a takeaway. And then I've got 3 and it's going to be v over v. V over v, v plus 1 again. Because the v plus 1 is still here, so we've got to times it by v. And notice I've just times the top by v and the bottom by v. To make for balance, I've done that and that. Then the bottom can stay the same because we've got the same denominator, but the top needs to be expanded. 4v plus 4 minus 3v. 4v take away 3v is just v. V plus 4 over v, v plus 1. And I think you'll all agree that's v good. I'm sure I've just lost anyone who was viewing and was trying to learn about this. I just left the video, but never mind. For the second one, I'll change colour just to make it so we can see that it's different working. First step, as always, I'll try and use a thinner thing. I believe I can add these to the thing. I'm going to times that one by 2k minus 3. K minus 3. I'm going to add a second bracket because it makes it easier. And then the same on this side, 2k times k minus 3 and k minus 3, 2k minus 3. You could have written it the other way around. I just like to have the brackets the same way around on the base, but I like to have the single term in front, which is why I've rearranged it. We're then going to do some expanding. Be careful with your expanding. 2k squared minus 3k minus 2k squared, and this is the bit that I really want to make sure people don't make silly mistakes on. This calculation here is minus 2k times minus 3, which is why it gives us plus 6k. This is the reason I'm going to do plus 6k on the top. If you do not understand that, stop, rewind the video about 10 seconds, watch it again. That is minus 2k times by minus 3, which is why it's plus 6k. The most common source of dropped marks, I think, in the history of maths. Maybe. We don't know. This is quite nice because the 2k squared cancels with the 2k squared, takes it away. 6k take away 3k, we just end up with 3k on the top, and k minus 3, 2k minus 3. Nothing further cancels. Please remember this 3 cannot interact with either of these 3's because they are each inside brackets, so you mustn't cancel them. They do not access them. If you find yourself tempted and your pen's going towards the cancelling, go, no, I must not, because that 3k belongs to that, and that belongs to that. And then, sir, you've got highlighter all over our lovely work. Okay. I don't know if it's possible. I've managed to get rid of the 3 and not the highlighter. That's clever, isn't it? I'll leave the highlighter on the bottom just because it makes more sense. Okay. So we will go head back over to here where there's a few more questions for you to do. If you want to look at these questions, again, pause. You've had your warning. Here's the answers. Again, I've broken down in them, or someone else has broken down for me, how each question is worked out. So you can follow through what you were supposed to do. This means that you can check that you know how to do it. This video you will not get the most out of if you just watch it through once, never pause it, and don't do any of the questions. Maths at a higher tier GCSE level, you cannot be successful just trying to hear what a teacher says. We learn way more from what we do than what we hear. I've tried to explain it. The only way to really master something is to go away and do it. We also have one more level. This is where they've got brackets on the bottom. I am not going to do an example of this because this is the example I've just done in the other page. You will notice this is the first example I did in the other page. I did the first example of each page. I'm going back. I did A on here and I've now done A on here. So if you want to go check out how to do these because you're a bit stuck, go back and watch the bit I did on the whiteboard. Pause the video. You've had your warning. And there's all the working. It looks a bit complicated and messy, but I assure you, it really is okay. You're absolutely safe doing this. You will soon find, after about 4 or 5, you're starting to get the answers correct. Or there's something basic in your understanding that is the mistake. Now, I have deliberately made this page negatives. And this is because the big mistake people make is when they're taking away a minus. You will notice it's minus and minus. That trick I tried to highlight with you, I wanted to give you practice at that. So you'll notice they're all minuses here. If it's pluses, I think they're easier because you just add everything together. It's when you've got a minus. So as you can see on the top of A, it's minus 3k minus minus 6. Minus minus is a plus. Hence it's plus 3k. That's why we've got these things. So just be careful with your minus and minus. So in review, I don't really want to read those to you because you can read yourself. But we talked about factorising and being the root of where this has all come from. We talked about how to simplify fractions when there's algebra involved in them. We then talked about how to add and subtract fractions. Hopefully this video, although it's possibly only taken, me 15-20 minutes, it possibly has taken you an hour because I would expect you pausing and completing all the questions. If you want to get feedback, feel free to email me at the normal places. You can send your copies of your work, but please mark them yourself. Then I'm happy to correct anything if you can't see where the correct answer was. You need to circle it and show which bit was wrong and query where am I going wrong. If you just send me work that isn't marked, I haven't got the time to go back to all the answers and work out where you were wrong. But if you send me it and you've got one wrong and you can't see why it's wrong, more than happy to help out. If it is wrong, write down the correct answer on the page so that we can compare them. So here's your challenge. There's a worksheet. You can see the link there. That link will also be in the video in the description below. If you don't want to have to type it out, you just want to click it. Just click show more below the video, and that's where you can go and do some more algebraic fraction stuff. There's a Taskmaster challenge this week. So you need to make a Where's Wally or Where Am I Hiding picture and send it to Mr. Harris. And that's for all the different year groups that I'm doing lessons for. Feel free to get involved. I'd love to see if you can hide in plain sight. Finally, sharing. Please do, if you found this at all useful, share it to someone else who you think would benefit, or 2 people who think would benefit. It all helps me to grow the channel and to get better feedback for you and make these videos better. Thank you very much for joining me. I hope that I've been audible. I hope you've understood what I'm doing. Not been particularly funny today, but it's a topic that's a little bit drier. So, thank you very much for joining me. I've been Mr. Harris. You've been awesome. Goodbye.